Hi dear students, welcome back to my session. In our previous session, we have seen one of the problem which is related to Kirchhoff's laws. We name it as a circuit analysis techniques. We used two laws, Ohm's law and Kirchhoff's laws. Based on those laws, we wrote loop equations. Under the loop equation, we classified into the two ways of solving of the finding branch currents by using the based on the branch currents equation or based on the loop currents. Based on those two methods, we wrote a equation. Based on the writing of equations, we solve branches of individual elements. So we solve the currents for the individual branches. So this is continuation of our previous session, and in this session also we will solve few problems by using the Kirchhoff's laws. Right. So today this is a problem which we are going to be discuss in this session. If time permits, I will discuss one more problem also. So let's have a look at this problem. Right. Find the current in 5 ohms resistor branch by applying Kirchhoff's laws. So here he given clearly which thing you need to be used by finding the 5 ohms resistor. Kirchhoff's laws you need to be follow. Rather than this, you should not follow any other laws. I can say nodal analysis, mesh analysis. Don't follow those methods. Those methods will come under your graduation level. But as per your diploma level, this Kirchhoff's laws method is enough for you guys. So you need to be follow only Kirchhoff's laws, and you should not depend upon the mesh analysis and nodal analysis. Those methods under the graduation level. So as of now, don't mess up your mind. So Kirchhoff's laws method is enough for you guys. If the time permits, I will discuss mesh and nodal analysis if you are interested. Right. So let me understand the circuit. In this circuit, he given two voltage sources. One is 60 voltage source, one is 40 voltage sources, means two active sources, three passive elements, 10, 5 and 10. Let me name it as this is R1, this is R2, this is R3. This is source V1 and source V2, right? There are two sources, two active sources and three loads, 10, 5 and 10. Now he wants to know current flowing through the 5 ohms resistor. 5 ohms, how much? So he wants to know the current through the 5 ohms resistor. For this, as per our previous session, we have the two methods for the writing of loop equations. What are those methods? Based on the branch currents, based on the loop currents. So here we need to be follow only one method, because if we for that, by using that method only, we will solve all the equations. Let me follow first branch currents methods. I am following the based on the branch currents. Based on branch currents. Based on the branch currents, I hope you guys know the rules. There are a set of rules are there for that method. In our last session, we wrote a total of 6 rules. Based on those rules, we will follow strictly for the writing here. Let me redraw the circuit diagram again. First, as per our rule number 1, based on the branch currents method, we should assume as a loops. How many which we should assume as a branch currents? How many branch currents we need to be assumed here? 2 loops. Number of loops 2. We should assume 2 currents only, I1 and I2. 2 currents we need to be assumed. This is rule number 1. Let me assume those 2 currents only. Let me write 2 currents. Next, as per rule number 2, consider any one of the active sources as a primary for flowing the primary current. Do not consider more than one incoming current. Here there are 2 active sources. One is 60 volts, one is 40 volts and 40 volts. Here among these 2 active sources, you need to be considered only one active source for the indicating of your branch currents. So for these 2 active sources, which is a higher one, 60 volts will be higher one. So that is the reason you need to be considered 60 is a active source. For the 60 is a for incoming currents for this rest of the branches. So 40 is you are not considering for as a incoming current. So let me consider as a 60 volts. Next, what is the rule? Rule number 3, I am considering 60 volts. 40 volts I am not considering. What is the rule number 3? Mark the current directions in a various branches. That means naming of branches. So this is naming of branches. So what are the currents? It will comes here. What are the currents? Let me naming of branches as per the rule number 1. You need to be assume only 2 currents. Let me assume 2 currents only. First, before this making the application of this rule, you need to be active one of the source. You need to be considered 60 volts. I am going to be considered as soon as consider this 60 volts. As soon as consider this 60 volts, this is a negative and this is a positive. Current always moves from here, right? Negative to positive. Don't consider this direction. Negative to positive, currents always move from here. So this is the current direction. Don't write this loop equation. Always name it as a branch current. So as soon as you switching on the supply, this will deliver some certain current. I am naming that current name is I1. When it is reaches this node, this is a node. When it is reaches this node point A, this is going to be splitted into the 2 ways. If I make this is I1 current, this obviously this is I2. Hence, the rest of current will be I1 minus I2. Higher current minus already releasing current is nothing but a rest of current. Incoming current, already releasing current is equals to rate of E is equals to rest of current. So this is the current which is flowing through this 5 ohm resistor. So now what are the naming of branches? One branch name is I1, second branch name is I2, third branch name is I1 minus I2. These are the naming of your branches, right? Next, what is the rule number 4? Rule number 4 is signing of branches. You need to be signs. Signing of branches, you need to be sign on the branch. So sign means you need to be indicate plus and minus as per the direction of branch currents. So this is the direction of already for this battery the signs already given, right? So this is I1 minus I2 is base comes here. So this is incoming for this branch I1 minus I2. Then the signs are plus and minus, and for this already signs are given. For this I2 is incoming, the signs are plus and minus. Hence from here I2 will comes, from here I1 minus I2. When it is meeting this B node, I1 minus I2 plus I1 minus I2 plus I2. Hence the releasing current is equals to I1. Both are same, right? Entering current should be equals to leaving current, I1 and I1, right? So when this I1 is reaching this point, the plus sign minus sign is like this. So this is the way of indicating of signs in particular branch based on the direction of branch currents. So you should concentrate on these rules. Based on these rules, you are writing all these things. Next, what is rule number 5? I think rule number 5, apply KVL to the closed loops by representing the loop numbers. So I am applying KVL. Naming of loops. Naming of loops. Now I can minimizing those lengthy words by making this shortcut. So I'm not writing all those rules over here. I'm writing only those shortcuts here. By writing all those rules again, it will be complicated for the representing in video. So here I am making the naming of loops. So how I can name those loops? So here I am following this direction, right? I1. So my loop direction should be always should be positive. I am following clockwise direction. Let me follow clockwise direction for this loop. This is my direction. This is clockwise. Already you fixed on your session number 7. On the session number 7 you made some rules. So on that 7 I am making this loop 1. This is loop 2. What are the naming of loop names? Loop 1 and loop 2. Right. Next, rule number 6. Write loop equations. This is rule number 6. Now let me write the loop equations. Loop equation by applying the KVL. Apply KVL. Here he says clearly use Kirchhoff's laws only. That is the reason I am naming it applying KVL for loop 1. Here this is the loop 1. I always used to follow from battery. For the battery, the leaving sign is negative, -60, and for this let me indicate this clearly. I am writing loop equation for loop 1. So I am moving from here. Right. So leaving sign is negative. I mentioned leaving sign. Next, from here, the leaving sign is for this. For leaving sign, positive of voltage drop means entering of I1. Hence, the voltage drop is 10 I1. Next, for this the leaving sign is positive and the voltage drop is I1 minus I2 into 5. Hence, positive 5 I1 minus I2. Hence, this is closed. Hence we have only following leaving signs, positive. There is a reason for the battery it's we got negative, and for the resistance we got positive because we are following the leaving signs. But as per the direction, for the current direction you are not following, you are following based on your loop directions for the writing of loop equation, right? Next, for the loop number 2 is equals to 0. How this equation will be, let me do some reduction of this equation. -60 plus 10I1 plus 5I1 minus 5I2 is equals to 0. 15I1 minus 5I2 is equals to 60, right? You can write 3I1 minus I2 is equals to 12, right? Let me write this equation number 1. Now apply KVL for loop number 2. Apply KVL for loop 2. This is loop 2. Let me start from battery. Always I used to follow from battery. So from battery, clockwise, right? So this is the downwards. The leaving sign is minus. The leaving sign is right. For this, the leaving sign is minus 40. For this branch, 5 ohms branch, the leaving sign is minus, right? Hence minus 5 I1 minus I2 voltage drop, minus 5, and this is the voltage drop. You are always considering voltage drop for the writing of loop equation. Always you should be equals to 0 by supplying voltage is equals to the by dropping those voltage. But if you give the 100 volts, 100 voltage should need to be utilized in that complete loop. 100 volts is going to be utilized by some of the loads, either maybe resistive load, inductive load, or capacitive load. But that 100 volts need to be utilized. That is the reason you are considering as a current and resistance, that is voltage drop. Minus 5 I1 minus I2. Next, for this is the direction. I am following the leaving sign. Leaving sign is positive. 10 into the current is I2 is equals to 0. Let me recheck it. A leaving sign minus 40, right? This is a leaving sign minus 40, correct? And for this leaving sign is minus 5, correct? And for this leaving sign is plus 5, and the current is I2, right? Let me do some mathematical part about this equation. Minus 40 minus 5I1 plus 5I2 plus 10I2 is equals to 0. Hence the equation will be (5I1) minus 10I2 is equals to minus 40, right? Hence I1 minus 2I2 is equals to minus 8, right? Let me recheck this. Minus 60 plus 10I plus 5I1 60 right. Let me solve these two equations. 3I1 3I1 minus I2 is equals to 12. I1 minus 2I2 is equals to minus 8. multiply this equation with 2, hence 6i1 minus 2i2 is equals to 24. I1 minus 2i2 is equals to minus 8, and this will be minus plus plus. 5i1 is equals to 32. I1 is equals to 32 divided by 5. I1 is equals to 6.4. Then if we collect it, what is it? Right, should be 5i1, 5 plus 15, 15i2, and it will make common 5i1 minus 3i2, i1 minus 3i2, then it should be i1 minus 3i2, should be i1 minus 3i2. Let me write this equation clearly. Let's strike it out. Multiply this equation with 3. Hence, this should be 9i1 minus 3i2 is equals to 12. I1 minus 3i2 is equals to minus 8. Minus plus plus 36, it will be 36, right? Hence these two equations get cancelled. This will be 8i1 is equals to 36, 8, 42. Hence be 42 minus 36 plus 8, 44, and 44 divided by 8, 5.5. It will be I1 is equals to 5.5. If you know the I1, you can find the I2. Substitute this equation. This is equation number 3. This is equation number 2. Substitute equation number 3 in equation number 1. What is equation number 1? 3i1 minus i2 is equals to 12. Hence 3 into 5.5 minus i2 is equals to 12. Then i2 will be 12 divided by 5.5 into 3, 16.5. i2 will be 16.5. Hence i2 is equals to 16.5 minus 12. How much? 4.5. i2 will be 4.5 amperes and i2 will be 4.5 amperes. We got the two currents for the two branches, I2 and I1. Let me highlight those answers. This is I2 current, this is I1 current. So means you got the two currents. For this, let me write. You make this branch name is I1, right? I1 and this branch name is, based on this analysis, based on this assumption, the branch name is I2. What is the value of I1 current? I1 is a 5.5 amperes. I2 is 4.5. For this, what about this? This direction should be upwards. This is not downwards because the current is. What about this current through this branch? This is incoming current. This already released current. What about the rest of the current? Incoming current or released current is equals to rest of current. So it hence it should be, the name of this branch is I1 minus I2 as per this analysis, I1 minus I2, and hence 5.5 minus 4.5 is equals to 1 ampere. 1 ampere of current is passing through this 5 ohms branch. So this is the solution for this problem. Hope you guys clear about this, but while you are finishing this problem, you need to be redraw the circuit clearly by mentioning those currents. You should, as per your representing of this problem, you need to be redraw the circuit again. For the, while you are finishing this problem, you need to be redraw the circuit by mentioning all those currents on your solution which you received on your solution. This is 60 volts, this is 40 volts, this is how much ohms, right? This is 10, 5 and 10, 10 ohms, 5 ohms, 10 ohms. So this is minus, plus, plus, minus. Now let me indicate the currents clearly. This is current of 5.5, this is current of amperes, this is 4.5 amperes, this is current of 1 ampere. So you should indicate clearly of these directions of currents, then only this is called final circuit by representing branch currents. That's it. Let me move to the next problem. Right, this is second problem for this session. What is the problem is given? Let me read the problem carefully. Find the currents in each branch by using Kirchhoff's laws. So in this problem he is asking for the currents for each branch. Here how many branches? For this complete one branch I can name it as a 1, 2, 3, 4 branches is there, but this is common branch and this is common branch. This is the total 3 currents he required. So by using the Kirchhoff's laws. So for this, let me write the rules for here also. But before writing the rules, you are following based on the branch loop equation, based on branch currents. For this, here we have two loops. You need to be followed 2 imaginary currents, I1 and I2. Right. Next, what is it? Rule number 2. You need to be considered only one of the active source element. Here total how many elements? 15, 15, 15, and 25. In our previous session, we took it as a highest value of the voltage, but in this session let me follow the lowest value of voltage. Is that we will get a answer or not? We can check it in this session. I am not following the highest value. Let me follow the lowest value, 15 volts. For the left side I am following this. There is no rule you need to be follow the highest value of voltage. There is a rule only you need to be follow only one active source. Either maybe 15, 15, 15. You can follow only one of the active source. Either maybe low voltage or high voltage, that is doesn't matter. But our basic fundamental as electrical engineer, we are always the highest value of voltage will be always is in delivery mode. Lowest value always in lowest value of voltage, and some other elements are the receiving mode. So here I am following the for this problem I am following the lowest value. It means 15 volts. Next, rule number 3. What is the rule number 3? Rule number 3, I can naming of branches. So let me write the naming of branches. So here I am considering this is the loop. For this I am naming of branches. I am not going to be redrawing the circuit again. This is for my session. This is a waste of time. You guys need to be redraw this circuit again here. Then you need to be indicate those assumption of current in particular branch. So I'm directly indicating those values in the problem itself only. I am not going to be drawing here again. So here this is a value I am making active. I am not going to be active those sources. Here this is the delivery mode. The current is coming from here. As soon as the switching of the supply, let me take this I1 current. This current will go to here I1, and this current is go to here. From this current is divided into the two ways as per the law of KCL. Current is entering current at a node is equals to current leaving from that node. Let me take this is the node of I2. What about this name of this branch? I1 minus I2. Then your assumption currents are I1, I2, I1 minus I2. Right. This is rule number 3, and rule number 4, indicate the signs. I am going to be indicate the signs. Let me indicate those signs clearly. As per the direction of branch currents, I am going to be indicate those signs positive, negative. For here, all the signs indicated, and as soon as the current is moving over here, I1 minus I2 current, and this current is positive and negative. This is name of current I1 minus I2, and as soon as this current is meeting this point, this is positive, this is negative. This is I2 of current releasing from here I2. This is positive and negative. Hence, this is two incoming currents for this node of B, and the outgoing current I1 minus I2 plus I2. I2 is get cancelled. The outgoing current is I1. Both are same. It should be incoming should be equal to the outgoing, right? This is positive, negative, and this should be this current of I1. This is positive and negative, right? Hope you clear about the directions. So these directions are very important. Based on this direction, you need to be indicate the signs. You should strictly follow rule number 4. I am indicating positive and negative signs. So positive and negative signs. So here I am done with the rule number 4. What is the rule number 5? Apply the KVL or draw the loop numbers for the loop currents, not loop current, for the writing of loop equation, and going to drawing the loop direction of your loop. I am following irrespective of the branch current direction. I always used to follow the direction of loop, like in clockwise. This is the loop direction. This is the loop direction. Loop direction, loop number 1, loop number 2. I am done with the loops. This is loop direction, loop 1 and loop 2. Right. Now rule number 6. Write the loop equations. This is the rule number 6. Right. Let me apply KVL. Apply KVL for loop 1. So I used to follow always leaving sign. I am starting from here. Let me start from here. Right. For here it will comes leaving sign positive. What is the leaving sign? Positive 15. Hence the leaving sign is negative of voltage drop, negative 5i1. Hence the leaving sign is minus 15, and the leaving sign of this branch is with the voltage drop minus 8 i1 minus i2, and hence the leaving sign of this branch is minus 5 of this voltage drop i1 is equals to, sorry, one more sign is there, minus 5 i1, and for this the leaving sign is minus 10. What about this current? Let me draw this current carefully. I1, the current is minus 10 I1 is equals to 0. Right, let me do some mathematical reduction of this equation. Minus 15 plus 15 get cancelled. Minus 5i1 minus 8i1 plus 8i2. Next, minus 5i1 minus 10i1 is equals to 0. 5 plus 5 10, 10 plus 10 20, 20 plus 8 minus 28, minus 28 i1 plus 8 i2 is equals to 0, or you can write I can write like this. I1 minus 2i2 is equals to 0. 7i1 2i2 is equals to 0. This is equation number 1. Next, let me write the equation number 2. Apply KVL for loop number 2. This is loop number 2. Let me start from battery. I'm following from here. Leaving sign minus 25. Right, leaving sign minus 25. For this leaving sign minus and with the voltage drop minus 10 into I2. Right, I2 only. I2 current is passing through this branch. Next, for this 8 ohms resistor, the leaving sign is positive. Let me complete this. The leaving sign is positive of that voltage drop. How much current? I1 minus I2. Then this is flowing through this voltage source also. The leaving sign is positive 15, and the leaving sign is positive 15. Next, the leaving sign of this resistor is minus. Let me draw it here. Minus half voltage drop. How much voltage drop? 10 into I2. Right, 10 into I2. Complete this cycle by connecting this line. Right. So hope you guys clear about the writing of these equations, and you know how to frame this equation. Simple if you understand the rules. Otherwise you will get a confused and you will do a lot of mistakes, and mistake on the signs only, signs itself only you will do mistakes. So you should clear about this writing of this equation. Whatever I am indicating in orange color for the writing of this equation is very important. Now the doing of mathematical part is very easy. As you are engineering student, it is very easy for you guys for doing the mathematical part. I never care about this mathematical part. I always care about for the writing of this equation. So let me reduce this equation. Minus 25 and plus 15, it will be minus 10, and next minus 10i2 plus 8i1, next minus 8i2 minus 10i2. Is there any common terms? i2 terms are more. Minus 10 minus 8 minus 10, it will be 10 plus 10 20 minus 28, minus 28 i2 plus 8 i1 is equals to 10, right? Let me take common of 4 again. It will be 2i1 minus 7i2 10 by 4 is nothing but a 5 by 2. It will be 2i1 minus 7i2 is equals to 7i2 is equals to 5 by 2, right? This is equation number 2. Let me solve these two equations, or otherwise put one of the equation in two equation. How you can put, let me write this equation in this way. I am writing this equation from equation number 1. I am writing 7i1 is equals to 2i2. Hence i1 is equals to 2 by 7i2, right? Put this value equation number 3, put equation 3 in equation 2, then you will get a clarity. Instead of i1, put this value, hence it will be 2 into 2 by 7 i1 minus 7i2 is equals to 5 by 2. Hence which will be 4 by 7 i2 is equals to minus 7 i2 is equals to 5 by 2 is nothing but a 4 by 7 i2 minus 7 i2 is equals to 5 by 2. It will be 4i2 minus 49 minus 49i2 divided by 7 is equals to 5 by 2. You can see it will be minus 45i2 divided by 7 is equals to 5 by 2. Hence it should be 5 nines are, and the i2 value will be minus 9 by 7. I2 is equals to 1 by 2. Then I2 will be 7 by, I2 will be 1 by 2 into minus 7 by 9. I2 will be minus 7 by 18. Right, this is the I2 value in amps. Now you got the I2 value. Put this I2 in let me put that value in equation number 3, then you will get I1. Put this value, let me write, this is equation number 3, equation number 4. Put equation 4 in equation 3, right? Am I correct? Right, equation 3 only. What is equation 3? I1 is equals to 2 by 7 I2. I1 is equals to 2 by 7 I2. Am I correct? I1 is equals to 2 by 7 I2. Is it minus or plus? Plus only. 2 by 7 I2. And hence I1 is equals to 2 by 7 I2 value is minus 7 by 80. Hence 7 is gets 2 9s are. Hence the I1 value will be minus 1 by 9 amps. This is equation number 5. You got I1 and I2, then you can find I1 minus I2 easily. You need to be find I1 minus I2 now. Now the value of I1 minus I2 will be, what is the value of I1? Minus 1 by 9. I2 will be minus of minus 7 by 18. Hence it will be 1 by 9 minus 1 by 9 plus 7 by 18. If I do this, 18 2 minus 2 plus 7, it will be 5 by 18. Hence my value of I1 minus I2 will be, the current flowing through the branch of 8 ohms resistor is I1 minus I2 is equals to 5 by 18 amps. This is the solution of this problem, equation number 6. So now for the summarizing of this problem, you need to redraw the circuit by mentioning of these 3 currents in the circuit. So let me redraw the circuit again. These are the every battery have 2 resistors, right? And here I think here I have some resistor, and here I have some resistor, here must have some resistor, right? This is 15, this is also 15, this should be 25. Let me check it again. And this is 5 ohms, this is 10 ohms, this is 5 ohms, this is 8 ohms, 10 ohms, and 10 ohms. Let me check it again. 15, 5, 15, 10, 5, 8, and 10, 10, 25, and 10, right, correct. So here for based on the directions as per your assumptions, this is the directions, right, from left to right. Why the directions you choose based on the considering of this 15 volts battery source. If you consider 25 volts, you will get some other signs. Instead of negative, you may get positive, because what is the meaning of negative sign? So I am trying to summarizing about the negative sign here. The whatever your assumption of the direction is completely reverse, means your assumption of direction is from left to right. It means the value is minus, for this direction only the value is minus 7 by 18. If you make this value instead of negative, if you make this value positive, how you can make this value as a positive? If you reverse this current, instead of minus value, it will become a plus 7 by 18. When this value will become a plus? If 25 volts is active. So by using this Kirchhoff laws, you can finalize the direction of the branch currents based on your assumption. If you can conclude your assumption is correct or not. Now you are concluding is your assumption is wrong, right? Because why I am saying your steps are not wrong, your assumption is wrong, because here instead of 15 you are instead of 25 volts you are making activating of 15 volts. By looking these three sources, easily you can 25 volts is larger. Why can't you choose a 25 volts is for giving of supply those resistive branches? But here you are choosing in different way. Here you are choosing activating of 15 volts, considering the 15. That is the reason you are getting answer of negative value. Your processor, everything is correct. By making conclusion, how you can make the conclusion like this? Instead of giving the directions from like this, you should give the directions for like this. How you can give the directions for this I2? Let me write, where is I1? This is I1, right? This is not minus 7, minus 1 by 9. I1 will be minus 1 by 9. Instead of making, don't write currents again here. Don't write I1 minus I2, I2. Don't write the currents again here. Don't indicate the signs again here. Don't write anything. Just indicate the currents with the arrow marks. For the final circuit, you should not do all these things again. You should mention neatly and clearly currents of the branch with the direction only. Don't mention anything of your rules. And wash up those rules. Just indicate the only current directions with the value of the current, right? With value of current only. Don't write again I1 and I2, I1 minus I2, right? Here the direction is, the assumption of this branch is I2, right? For the assumption of branch is I2 and the direction is for this, your assumption is this. But your results I2 is reverse. So then I am making reverse. How? This is the value I got, this 2, 3 values I received. Now I am making a reversing. The value is I1 value is I1 for this 1 by 9 amps, right? Next value I2. For where you indicate the I2, I indicate the I2 over here. For this complete branch, I indicate the I2. For this, I assume the direction is like this. I assume like this, but this direction is wrong. How I got wrong? How I got to know it is wrong? Because here the negative sign is came. That is the reason I completely reversing of those directions like this. This value will be, current of this value will be 7 by 18 amps, right? And what about this? This is came with the positive sign, means whatever your assumption is correct, means downwards. I assumed the direction of downwards, hence this value is not changed. What about this branch currents? 5 by 18 amps. if you add these two values, 5 by 80, sorry, this value means this value is nothing but a 7 by 18 minus 1 by 9. So this is final circuit of branch currents. So you should very clear about the circuit. You should not mention anything apart from the direction of currents. That's it. So this is today's session. Hope you guys clear about this. And next class we will discuss a few more problems. Next class we will discuss few more problems, and you should clear about the directions, and you should very clear about this indication of signs. You should very thorough about the writing of loop equations, right? You should follow only one method based on the branch currents. If you very flexibility about the second method, that is based on the loop currents, you can follow it. That is doesn't matter, but the way of procedure is important, right? Thank you. Today I am winding out, right? Thank you. Have a good day. Bye bye.